Hi, everybody. Hope everybody's having a good day. How's things going? Okay, we're going to continue our discussion on exponents and comparing them to, remember, we're comparing them to lines. Hope everybody's doing well. Mr. Byrne and I will be getting together and trying to find more ways to torture you, so just be happy. Okay, we're working on exponents, and let's take a look at the document here. Okay, so remember yesterday, the big thing about yesterday, okay, was the difference. Let's just review. The big thing about yesterday was we had for lines and for exponents. Okay, for lines, we had y equals mx plus b. For exponents, we had y equals ab to the x. Okay, and let's look at m, for example. M was slope. And when m was positive, we said the slope was increasing. When m was negative, say negative, the slope was decreasing. That's from yesterday. This is all from yesterday. Now, that should be old business there. We should know that. That should make sense to everybody. So for exponents, remember b, okay, b was, we don't call it the slope. Okay, b was the change. Okay, when b was between 0 and 1, we said that we called that exponential decay. And when b was greater than 1, that was growth. Okay? And for example, decay looked like this. Decay was going down. Started at infinity and went down. And growth started here and went up. Okay? Do you see that? And remember, we had another new thing about exponents about this. Remember, there were borders. Okay, this x-axis right here was a border. It was called an asymptote. Okay, it never crosses. That's called a horizontal asymptote. It never crossed that. So when you're graphing it, if you cross that line, that's not good. Okay, don't cross that line. Okay? And then we said yesterday, the b for this one was the y-intercept. Let's change colors here. Okay, we had b. Okay, so b is the y-intercept. Well, here, A is the y-intercept. So those are the things you want to relate it to your old, what you knew about lines. Those are the things that get confusing there. Okay, right here, when x is equal to 0, that's the y-intercept. Okay, whereas this letter we used B, this letter we used A. That's just a review from yesterday. Now remember, you could look at yesterday's work and pause and take a look at that because we're going to do the same thing today. Take a look at today's stuff. Here's another example. Okay, so here's our line. Hopefully you recognize that as a line. That shouldn't be too bad. Plug in 0. Our y-intercept is 100. Plug in 1, we get 102. Plug in 2, we get 104. Plug in 3, we get 106. Pretty easy. What is 100? 100 is the y-intercept. And what's the 2? The 2 is the slope. Let's just quickly go through that because hopefully we should be pretty good. Now remember, if you're stuck on something, you email me, email Mr. Byrne. Say something if you're stuck on that. But that should be old business. Okay, so now let's look at the table here. Let's do the same thing. Let's look at the table right there. Okay, I plug in 0. I get 5 times 2 to the 0. Use your calculators. I get 5. I plug in 1. I get 5 times 2 to the first. I get 10. I plug in 2. 5 times 2 squared. 2 squared is 4. I get 20. and plug in 3. 2 to the third. 2 to the third is 8. So I get 40. Okay, so right away we know that's not a line. Okay, so now let's take a look. What happens to y as x goes up by 1? So every time x goes up right here, y increases by what? By a factor. By how does it increase? It increases by 5, then it increases by 10, then it increases by 20. You see? Okay, so y increases by times 2. You see? Now, we don't call it the slope, but you could see the 2 inside the problem. What happens to y as we increase x by 2? Okay, if x goes up by 2, y increases times 4. You see that? Okay, so notice this here for addition, this is as x goes up by 1, it increases by plus 2 every time. And if it goes up by 2, plus 4. It goes up by 3, plus 6. Plus. Whereas exponents, it's times. So times 2, times 2, times 2. Okay, so what is the 5? Okay, the 5 is the y-intercept. See? Right there. 5 is the y-intercept. What's the 2? Okay, what is the 2? The 2 is the rate of change. Rate of change. But it's not the slope. Don't say it's the slope. Okay? 2 is how much it goes up by every time. The product. Okay? So, for example, let's do a little problem here. Okay, a little data modeling. Okay? What we got here is we got the situation here. We got a times b to the x. Okay? And the variable is increased by 1. And the value of the response variable is multiplied by b. That's what we were just talking about. As x goes up by 1, b is the multiplier. Okay. So for example, let's take a look at this function. A times 10 to the x. What happens to the value of the input when it increases from 20 to 21? Okay, think about it. Okay. What happens to the output? This went up by 1. 20 to 21. So x went up by 1. So what happened to the output? Okay, the output went up by, now look at the wording they use, up by a multiple. Put a multiple of, what do you think? There's the number right there. Multiple of 10. Now, if you're unsure, let's plug in some numbers. Okay, so we'll just say 10 to the 0 is 1. Use your calculators. 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000. You see, x is 0, x is 1, x is 2, x is 3. As the input goes up by 1, times 10, times 10, times 10. It's a multiple of 10. Okay? What happens to the output as it goes from 30 to 32? Oh, it went up by 2. It went up by a factor of 2, so it's times 10, but then times 10 again because it went up twice. You see, from 30 to 32, it goes up twice. So it went up by a multiple of 100. 10 times 10. 100. And basically what they're saying is like slope. You know, when slope changes, when you go from 5 to 10, that's 4 or 5 pluses. You see, 5 to 6 is 1, 6 to 7 is 2, 7 to 8 is 3. It goes up adding every time. Well, here, it's multiplying every time. That's the only difference. Different letters, different symbols, but it's multiplying every time. That's what exponents are. The rate changes with multiplying, not adding or subtracting. That's the key. Okay, so let's take a look at the picture. Okay, here's our table of data. They gave us a table of data here. Okay, and in that table of data, take a look. 0 is 3. 6, 12. What's that multiple? Times 2. Times 2. Let's go backwards. Divide by 2. I'm going that direction. See, this direction times 2. This direction divide by 2. Oh, look, the base is 2. Multiply by 2 every time. You see what I mean? Whereas I'm going backwards, dividing by 2. This is, since that base, remember how back in our rules, this rule sheet is the most important sheet you should have. Okay, that base is greater than 1, so this is growth, and it looks like that. Oh, look. Looks like that. It's growth. Whereas this one, look at this one. From 2 to 1, divide by 2. Divide by 2. Divide by 2. If I'm going that direction. Go back this way, times 2. If we're going backwards, times 2. You see how that's opposite of this. Notice the base is 1/2. Right there. Well, if it's between 0 and 1, that's decay. Now remember, here was positives and negatives. This is not positives and negatives. This is between 0 and 1 is the decay, going down like that. Greater than 1 is growth. There's your difference right there. Okay, let's read. In both cases, A is greater than 0, which, okay, we can see when B is greater than 1, the graph is increasing. And the second graph, B is less than 1, is decreasing. So there's our definitions. We called it growth and decay. Okay, exponential growth is when A is greater than 1 and B is, I'm sorry, let me read. The A is greater than 0 and B is greater than 1. This is the key. B is greater than 1 like we said already. Okay, exponential decay, A is greater than 0, of course, same thing. But B is less than 1. Now remember, B can't be negative. So that's why we've been saying B is between 0 and 1. So there's our two definitions. Highlight that. Let me highlight those. Exponential growth, exponential decay. That's the two words that we were using in this sheet right here. Again, this is your note sheet. This is what you use to study, especially with the quiz. It's open notes. This is what you have for it. Okay, let's try another problem. Okay, here's an example. So they gave us a situation. They gave us a table of data. Let's try to figure out what this table of data is. Okay, notice, let's see what we see there. I see at, oh, sorry, kind of hard to see. Let me pull it up online here. That's kind of hard to see. At 0, it's 3. All right, let me put that in there. At 0, it's 3. At 1, it's 6. Okay, so just like any 2 points with slope, now we got the idea. Let's see what happens. How did I go from 3 to 6? Times 2. So at 2, it's got to be 12. At 3, it's got to be times 2, 24. At 4, times 2, 48. You see that? Okay, so just given those 2 points, just like we would for a slope. So let's see how we got it. Our y-intercept, our a, remember our formula. Let's write our formula. Y equals a times b to the x. A is the y-intercept. A is the y-intercept is 3. B is the growth. The growth is times 2. So b is 2. So our equation is y equals 3 times 2 to the x. Remember, you could pause the video when you're watching and try it before I try it. That's a great way to learn. Oops, sorry. That's a great way to learn. Pause the video and then try the problem, or just look at the problem afterwards. All right, this is old business. X is 1, so y is 6. X is 2, y is 12. Ooh, now y is 3. You see, here is x is 1. X is 2 is what the question is saying. Now it's saying y is 3. Just reading the chart. Y is 12. When y is 3, x is 0. When y is 12, let's find it. 12, x is 2. You see what I mean? That should be old business here. We should remember how to read that, reading our chart from there. You see how we did all that? Let's try one more example. Okay, take a look at this one, another picture here. And let's see what the data we got here. Like I said, I need got to zoom in on this. This is a little tougher for me. Okay, it looks like at 0 it's 2, and at 1 it's 8. At 0 it's 2, and at 1 it's 8. All right. How did we move? Remember, no adding or subtracting. How do we get from 2 to 8? We're looking at, this looks like growth. That looks like growth right there. So it's times 2 to 8 times, not plus 6, times 4. All right, so now I get the calculator out. 2, 3. How do I, 8 times 4? 32. Oh, I don't even, let's see what 32 times 4, 128. See, times 4. You see how it grows really fast? It's not like lines here. It grows really fast. Okay, so let's see. The y-intercept, remember, y equals a times b to the x. The y-intercept, right there, a is 2. And the growth, the b, is 4. The best way to think of it is like lines. Okay, oops, sorry, hit that again. The best way to think of it is like y equals mx plus b. You got your y-intercept and you got your growth. The growth is times, not adding or subtracting like slope. So the equation is y equals 2 times 4 to the x. Now remember, you could always post a question on Schoology, ask us comments, send me an email, send Mr. Byrne an email, ask a question here. But you got to be following along. This is our last chapter. This is our last unit. 0 is 2. X, again, x equals 0. So what's y? X equals 2. Let's find it. 2. So y is 32. Backwards, y equals 8. Y equals 128. Going backwards now. That's just the notation. Y is equal to 8. X is 1. Y is equal to 8. X is 3. And there we go. There was today's assignment. Work through it. Watch the video. Send a question. Remember, this is on you guys. Okay, I can't go to your house and get you out of bed. I can't go to your house, but if you have a question, I'm always here to help you. So just send an email, send a message, ask Mr. Byrne, ask myself, because this is our last chapter and we got to get through this. Remember, this is our note sheet. Take a picture of it. Use this when you're taking the quiz, and we'll just keep going through this. Okay? All right, everybody stay safe. I will see you tomorrow, same time.